Okay, so let me create, so let's understand the architect of a Linux operating system here. How is it work here? So here you will get a more clarity. Let me make a one diagram here. Okay, and let me make a here one more here. So it is your end user. End user. Okay, it is end user. Okay, we are end user. Okay, it's an end user. Now let's learn here shell end user, and let me make as a shell here. Shell. So what is shell? Firstly, we need to understand what is a shell. And under user, end user, we learned we are an end user. What is a shell here? So let's learn that things here. Here. So shell is working as interpreter between user and kernel. Okay, so now let me make a kernel one more pic here. Let me draw a here. Okay, now this is my kernel. 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 Okay, so shell is working as an interpreter between user and kernel here. So here we have an end user shell kernel. So how it is connected here? So let us understand one by one, and let's understand shell also first. So shell is working as an interpreter between user and kernel. If I give an example like a layman, if I need to talk with a Chinese guy, I don't know Chinese, right? How can I talk with the Chinese people? We need an interpreter, right? So same as like shell is working as an interpreter. Shell language, shell is understanding your English language, because whatever we are writing the any command, it is influenced by a English syntax here. Okay, so types of shell. Let's learn types of shell. This is mostly we are using types of shell. Bash shell, warn, again shell, warn again shell. Second is KSS shell, mostly warn again shell, where it is using your Linux operating system. KSL shell, con shell, con shell, where it is using mostly AIX operating system. C shell, where it is using mostly, I have seen Solaris operating system. Fourth is a shell. It is a legacy shell, legacy shell of Bash. Well, Bash is a now upgraded. So, and fifth is a Jet shell. Okay, so it is a mixture of Bash, KSH, and TCSH shell also there. Okay, so I can say fifth is a TCSH shell, and I can make it a 6. So every shell there have on property. Okay, so let us understand how we are connecting with a Linux. So I'm using right now Putty. This is a putty software. So what is the meaning of putty? Putty is kind of a software. So where we can take a remote access of the server, like you are using a Windows, you are using a RDP there. Using a RDP is nothing, it's a kind of a software, and RDP is working on some protocols, right? So putty, we are using here we are using a SH port number 22. So let me close here. I'm closing here, and let me close this one also. Okay, so I have a putty installed on my desktop. Here I'm logging here. So here it's asking me a username because I'm using AWS here. So right now I have connected with the shell, and this is my shell where I can use a command. I'm writing a command here. This command is influenced by a English syntax. Okay, English syntax, right? In English, influenced by English here. Okay, we are not in English. Okay, influenced. Influenced by English. Okay, so it is influenced by English here. Okay, so how we connected here? Okay, so first we need to understand how we connected here. Okay, so I use this command and I got some output here. How it is actually, let's understand as a diagram here. So now I connected end user and I try to use a putty and make a session. Okay, make a session that called a Pasito terminal session. It is the location is deb pts here. Okay, so 0. So first terminal session established, then I got the shell. Okay, first it will create a session, then here. So now here, first I got a session here. So before that, now I'm going again. I'm using a putty here. Now I'm using a SH protocol. So here we will access our server using a SH port number 22. It is a secure shell. And now it will establish a connection here. So I'm using a EC2 hyphen user. Okay, so now it's created a terminal session. On the top of the terminal session, it created a bash shell. So first let's check a TTY. It is created as terminal session 2. That's I have mentioned here in a diagram. Okay, so it is established the session. After that, it established a shell here. How can I check a shell here? So please ignore today commands. I'm not teaching any commands. Echo $shell. I'm using a bash shell here. So bash shell, what it will work? It will work as an interpreter between kernel and end user here. So you type any commands on a shell here, and after that, here it is connected with the kernel. Kernel is not understanding your English language. Kernel is understanding format of 0 and 1 binary format. Here. So just it's understanding 0 and 1 format. Shell is understanding. So shell have established a connection with the kernel. So what it did actually here, it set up a connection that we called as a system call. System call. Okay, so that is a system call. It's established a system call. So what is a system call? What actually did here actually? So it created a process here. What it did here? Creating a process we called as a, I hope you heard about that, fork. Okay, and if I say in a Windows, if I'm talking about a Windows also, they are creating a sessions. So we called in a Windows created process. create process. Okay, so it's creating a so system we known as a system calls. In a system calls, which process they have created here. Okay, so it's created as a fork here to create a session here. Okay, if it want to read anything, it will use a read. If it want to write, it will make a write system call. Okay, if it want to open, it will make a open system call. So these are the system calls. So like that, the connection established between a kernel. Now you are end user. End user means you are a end user. Here you have open FOT and you make a session and you connected with the shell with the /dev/terminal session that I have shown you. That was the reason you are able to see this here. We connected. Now after that, I used a uname-a command here. I used a uname-a command. I got the output. So where I got the output? On the top of the screen. It means it display on the monitor. Let's understand the further now how your kernel is working here. Okay, now so let me make it a big here. So okay, so now here here it is. Let's make a one more diagram here and I can write here. Okay, so now here it is a kernel kernel device drivers, or we called as a modules or modules. Okay, so how is it working here? Okay, now this request came here, and after that, kernel will decide where this request should be go. Let's say this request goes to, you want to display here. Okay, where you want to display, where we want to display on a monitor, correct? Let me create a one more here. Okay, and I will give the name here, hardware. Okay, in hardware, let's say your monitor, your CPU, RAM, etc. Okay, lot of your LAN card, or we can make a your LAN card or etc. Okay, so now how your request came here? Now it request came here. So here, the request came here, and after that it will find out the respective drivers here. So you are using a Windows audio driver, we have a different drivers different. For a VLAN we have a different. For a VLAN, a LAN, and your Wi-Fi have a different. Everyone have their own drivers. So here let's say it is using a generic BZA driver. Let's assume here generic BZA. Okay, let's say it is using generic BZA. So this request will goes to here. It will find out where this request should be complete here. So this request will complete here monitor, right? So that was the reason you are able to see on the screen here. Okay, so what other workings? What are the other workings that's using by a kernel? So it is using other process like a process scheduling, inter-process communication. IPS is nothing, just it is a communication between your client and server and client, that called the inter-process communication. Your network management, your memory management, or file management, etc. File management. So all these operations handled by the kernel only. So kernel is handling all these operations here. So here we have type a command uname -a, uname -a, and user type the command. Shell, kernel is not understanding. Okay, so shell converted that command into a respective language, that is a 0 and 1. Kernel is understanding 0 and 1 format, and kernel after that it connected with a respective drivers, and after that it goes to respective hardware and you will get the output. Okay, so let's come on the shell part here. So here we have other components that comes here. So let me explain that things as well also. So here system component is coming in a picture here. Sys component. Sys component. Sys component let's take a daemon. So daemon, which daemon right now we are using in RHEL 7 or 8 onwards, we are using a system D. So what is a daemon? Daemon is nothing, just a process that runs in a background. That's running in a background. So right now you are accessing your you are accessing your Windows here. Okay, if I right click and if I go on a task manager, okay, here task manager, you have seen number of processes are running, but some processes are running a background. Or why it's running? See, these processes are, I have not opened anything. These are running in a background, that called as a daemon. So these processes are related to any other process that complete the part here. So daemon is nothing. It is just a process that's running in a background. It's not running on air like I have opened a Google Chrome, and Google Chrome is your front end. But I'm talking about a backend process. Backend process in Linux called as a daemon here. Okay, and whatever the commands we are using, these commands dependent on library files. Like same as like in a Windows, you are using a .dll, that is your library files. So here it's also using a some library file, C standard, like your live, or okay, like in a live it is using like a glibs. Okay, so in a C standard, so it's using some library files here. Here system D. So system D is the first process ID. It is a process ID here, having a process ID. So it is a process ID is a 1, that called a process ID is equal to 1. It is using earlier version. It was inner D. In earlier version, I'm talking about right now. Here we are, I'm talking about a like your RHEL 7 or 8 onwards. Okay, so here the process is using here system D, and older version that was in a D. Older version it is using right now also. It is using init D. Init D is a process. So right now we are using a system D process here. Okay, so like that your process has been completed here. Okay, so end user shell came here. If you think what is a shell, we are using a graphical user interface. So you can replace here, you can replace as a this part as a graphical user interface. Graphical user interface. Now end user, we here now we goes to here GUI, graphical user interface. Here also it's using in the backends. All this is sys component, daemon, system D, all this is C standard library also, and after that it will communicate with the kernel, and kernel will will talk with the respective drivers here, and after that it will communicate with your hardware, then you will get your results. So here it is a kernel. So kernel, what is a kernel? Kernel is the heart of the operating system, if I say. So everything is doing by a kernel. Process scheduling, IPC, network, memory management, file management, so many tasks it's done by only kernel only. Okay, so there are two parts here. One is a user space and another is a kernel space. Okay, so here okay, so here if I talking about here here, so this part we called as a user space. Okay, so user space, and here it is a kernel space. Okay, it is a user space, it is a kernel space. We called as a user space, we called as a kernel space here. Okay, so Linux is a monolithical kernel. Let's go for a deep about a Linux kernel. So Linux kernel, Linux is using monolithical kernel. We called a monolithical kernel. Okay, so where your user space plus kernel space are sharing same memory. Okay, so where Linux is using monolithical kernel, or Linux is known as a, I can say known as a, Linux is using, yeah, using the word as perfect here. Linux is using a monolithical kernel. Here, user space plus kernel space are in same memory location. Okay, and you have discussed about a window operating system. Let's discuss about a Windows OS. So Windows OS is a hybrid kernel. So hybrid kernel, it's using monolithical and microkernel. Okay, it's a combination of a monolithical plus micro kernel. It's using a hybrid. So what is a microkernel actually? Let's understand microkernel. Microkernel, user space and memory space are in different memory. So having on pro and cons here. Different memory location. So let's take a layman example. Suppose you have a roommate, right? If both the roommates are living in the same room, and if they want to communicate, is it more easy than compared to if your friends living in another room and you are in a different room? So who will do a conversation better? If you are in the same memory, same location, then Linux is using a monolithic kernel where user space and kernel space are in same memory. Okay, are a same memory. So suppose it is some address. Let's say address is like that, x123 something as a address. So it is sharing the same memory address. So if it is a communicating here, it's a more faster than compared to microkernel, because here, but cons is the what is the cons here? These are pro and cons. What is the con? Suppose something happened bad in a user space or kernel space, your process will be hanged, your operating system make a crash. So that is a drawback. Your Windows operating system, it's using hybrid kernel, it's using both monolithical plus micro kernel as well also.